This is for Year 12 methods that comes out of the Calculus SAC Trial, trial number 5, Tech Allowed 4A. Find the gradient of Tn in terms of A. So what have we got? We have this curved feature, which the early part of question 4 tells me that this is the rule for that curved feature. The tangent to f of x is either at n or m. When it's at n, it has a negative gradient and has a y-intercept of OA. Okay, the tangent, and there's limitations to the values that a can be. So I want to find the gradient of t to n. So t to n will be, if I say n was b and f of b, which is b and 3 the square root of 4 minus b squared on 2, then what I'd like to do is to find f dash of b, but in terms of a instead. So I'd like to find the tangent, and I'd find the tangent, and what I'd like to do is I'd like to find where the tangent touches for a line that also goes through this point. Now if I go back and have a look at the applications of differentiation, tangents that go through the origin, I use this idea where I set the derivative at a equal to f of a on a, and tangents that go through the point another point. So I've actually got this in this situation because I want to know where does the tangent touch the curve that go through this second point. And in this example, my second point is up here. So I want f dash of b to equal f of b minus a over b. F dash of b equals f of b minus a over b, because I've got a tangent that goes through this second point, and the second point is 0a. So its rise, if I was to consider a gradient triangle, its rise is f of b minus a, the new y value, and b minus 0. I'd normally have a b minus 0. Okay, so what I'm going to do is get my calculator out. Okay, so I've got my expression, which is this here, 3 square root 4 minus x squared over 2. I'll take the derivative of it, which is what this is. I'm going to use x instead of b. I've got this, which is f of b minus a over x. And if I go execute, then if I take that answer and solve for a, so interactive advanced solve for x, I get 2 answers. That tells me that it will touch at n or m. The negative will be m, so this is the value. So this is the value of b, that's where it's going to touch. So that's 2 square root of that. So if I put that into a new line, I know that the gradient of this will be the derivative given x equals that. So x equals, and if I come up here and take this derivative, copy, paste, given. So I'm going to take the derivative, so that will give me the gradient function, and I'm going to set the value of x to be that. So I'll press execute, and if I take my answer and I simplify it, there we go, and inside there I've got a squared minus 9, so the gradient should equal negative square root of a squared minus 9 all over, and I've just forgotten what it was, 2. But to solve this question, I needed to use this idea of a tangent will touch the curve and go through another point, and I used this as a way of solving it.